Hello, ladies and gentlemen. Sorry I couldn't be there for you guys for the live session, so that's why I did this recording for going over the answers. Okay, so let's get started. So you guys were supposed to do the catalyst and the objective and standard. Let's go on to the answers. So this one, what are the products when you mix a strong acid with a strong base? The products are just simply a salt and water. Okay. And just missed it. And what are the products when you mix a weak acid with a strong base? Now the key part here, strong base. If the base overtakes the acid, then the products would be a mostly basic solution and a possible soluble salt. Salt. Okay. For the next question, what are the products when you mix a strong acid with a weak base? And you can guess with the strong acid that would overtake the weak base. So the product will be mostly acidic and also a possible soluble salt. All right. Now for the next one, for number 4, what are the products when you mix both weak acid and a weak base? Just a neutral solution. They will cancel each other out. A neutral solution will be your product. Okay, now for this next part over here, what are the products? And what I said before, when acids and bases are mixed, you would want to look for the formation of a salt and also water. And also, these products will be a result from a double displacement reaction. So those are your clues, double displacement. Okay, and let me change my color there. Okay, so salts and waters would be the product. Let's see if we can make water out of this. We have a hydrogen here and hydroxide OH, so that would make your water. And also we have this potassium for the positive and the chlorate for the negative here. And switching these partners here from your double displacement, this one would give you a potassium chlorate, a salt. And let's just double check to make sure that it's all balanced. There are 2 hydrogens, good. There are 5 oxygens, 4, 5, good, and 1 chlorine. Yep, this is a balanced equation. And for this next part over here, taking these rules in mind, you can also guess that we would be making a water. Let's see, we've got H and OH here, so we can make water. And again, double displacement, we've got the anion here, the negative, and the positive for this one here. So let's put those together through double displacement. You will have magnesium sulfide. And let's make sure that this is balanced. So we have a total of 4 hydrogens. So let's put a 2 there. That would turn that into two oxygens. And double check, yep, we've got 2 oxygens there. And 1 magnesium here and 1 sulfur. Yep, so this is already balanced. For number 7, what are the products when acids and bases are neutralized? Going back to what I've said before, the products are salts and water. Right? And in neutralization, the number of hydrogen ions must be greater than the number of hydroxide ions. Going back to my video lesson, you'll know that this is false. The number of hydrogen ions must equal the number of hydroxide ions. That is the basis for neutralizing acids and bases, so that we form neutral products, and water is neutral. How are salts formed in neutral processes? Well, the anion comes from the acids, okay, while the cations comes from the bases. They come from bases, okay? And technically, that's how a salt is formed. In these acid-base reactions, the salt is technically the products from acids and bases, the positive and negative ions. Now, what is the difference between molarity and normality? Molarity takes the number of moles of the solutes or the compounds themselves, okay? While normality takes the number of moles also, but this time from ions, okay? Not from compounds. Remember, compounds are neutral, but the ions are the ones with charges, and they originally came from compounds that have dissociated into positives and negatives. Okay? For the next one, that should be a 2. Let me erase that. Erase. Okay. So that should have been a 2 there. Sulfuric acid, that's a pretty strong acid. It's asking you, why does H ion, why does the hydrogen ion have a normality of 2? 2N, 2 normality, 2 normal. Well, if you take a look at this compound here, you see that there are already 2 hydrogens. So there were 2 hydrogens in H2SO4. Okay? 2 ions will form. So once this dissociates, there will be 2 ions, 2 hydrogen ions for every sulfate negative anion. And what is the equation we use for neutralization? So that is simply the normality of the acid times the volume of the acid equals the normality of the base times the volume of the base. Okay. For this next problem here, we have molarity of sulfuric acid and also molarity of sodium hydroxide. So this is the acid and this is the base. The full question is, what volume of 2.0 molar sulfuric acid is required to neutralize 250 milliliters of 0.50 molarity of NaOH? Sodium hydroxide, which is the base. So we will use this equation here to figure out the volume of the acid. We're going to use this equation. Again, let me rewrite it out. Normality of the acid times the volume of the acid equals to the normality of the base times the volume of the base. And we are looking for the volume of this acid. So we can just rewrite this. Let's isolate the volume of the acid, make that equal to the normality of the base times the volume of the base divided by the normality of the acid. So you just need to figure out the values for each of these variables, plug them in, and you will get the volume of the acid. But we have to do a lot of preparations for that before we move on. So let me do this in a different color. So we know that the acid is H2SO4. So let's write this out. The normality of the acid will be H2SO4, and we have 2 hydrogen ions. So remember, there are 2 hydrogens here. That's how I got the number 2 there. But we also need to take into account the molarity. So you're going to multiply that with 2 times the molarity. And remember, molarity is moles per liter. And multiply those two, it is simply 4N. That is the normality. We have to take into account the actual concentration and multiply that by the number of ions that are dissociated. So let's do the same thing for the normality for the base. And we know for the base, This is an Arrhenius base. It will have the hydroxide right there. And that itself, there is one hydroxide ion that is dissociated for every sodium. So for that one, it'll be 1 times the molarity of the base. And we've got the molarity of the base right here, 0.50, 0.5, and molarity, remember, is moles per liter. And so the normality of the base is just 0.5 N. Okay. Volume of the acid is what we are looking for. That's our unknown. And let's find the volume of the base. The volume of the base is right here, 250 milliliters. 250 milliliters, but everything is in liters, so we got to convert the 250 milliliters into liters. And to do that, simply do 250 milliliters over 1, the conversion factor times, and then the line. We want to get rid of the milliliters, so that should be in the denominator down here. And there are 1,000 milliliters for every 1 liter. You guys remember that now? So cancel out the milliliters, and the volume of the base in liters is going to be 0.250 liters. Great, now we've got all of these variables to plug in here. Let me change it to my black pen again. So the volume of the acid will be the normality of the base. Right here, it's going to be 0.5 normal times the volume of the base. It's down here, 0.250 liters, divided by the normality of the acid, which is 4N. And we can cancel out the normalities there, the units of normalities. Take your calculator, use the Google scientific calculator if you don't have one. So just enter those values in. 0.5 times 0.250 divided by 4. The answer in liters will be 0.03125, and you can put that into liters, just multiply by 1,000. And there is, oh, sorry about that. And the answer is 31 milliliters. Okay, so that's how you do number 13. Moving on to number 14. Let's do number 14 then. But I'm gonna have to stop this video here, and you guys may take a break or you can move on. I'll see you next time in the next video.